Hello, good morning everyone. How are you all? I hope the live started. 1 second. Good morning. Oh my god. What is going on here? Okay. Hello, hi Narendra. No, that didn't happen, Joe. Sorry for delaying, but let me just check if I am I visible to you all? Okay, yeah, I am. Orientation, ma'am, please provide clear guidance. So, Naveen parent, sir or ma'am, the thing is the Comet K30 batch is starting from 6th of April. So, the orientation is, 1 second, let me check, remember. The orientation might be here today only. Just give me a second. Okay. Yes, today is batch orientation on the app. Yes, and yeah. Orientation, you have to attend orientation. You will get your login once you purchase the course, sir or ma'am. You will get the login details in your email ID. Okay, and from there you can log in the Diksha Vedantu app. That is one option. Second option is you can go to the Diksha Vedantu web page also. From there also you can log in and you can attend the orientation today. Okay, sorry sir. Okay, hi everyone. Hi. Yeah, I'm so late. No, I'm just 10 minutes late. Okay, not so late. Okay. Today there is no classes. Today is only batch orientation. They will tell you everything, how to navigate the app, how to access the lectures, how to access the tests, okay, how to access the DPPs and everything. They will tell you everything is in detail. So if you have purchased the course, you must attend the orientation, okay. Timing of orientation, good question. Let me just check once. Start around 9, I think. Once you log in, you can check in there. In here, it's showing today only from 8 to 9 it will start. Okay, so you can check once. And so even if you do not attend the live one, they'll be recording or something. If you're attending right now, that's very good. Or you can take as in a recording also, and you must go through it before starting the course. Okay. Good morning. Class time as in, yeah, good morning Sanket. Okay, yes, RCB. Okay, so you're still on that. Oh, let me start. So today we will be doing what chapters? We will be doing PU1 chapters. Okay, ma'am, please, class. Yeah, we're starting. No, I got late due to some other reason. Okay, let's start the class, Ravindra. Correct. So what I'm saying today, what we'll be doing, let me give you a quick briefing. Some basic concepts of chemistry, right? Sorry. We will be doing some basic concepts of chemistry. Should use this one. And some basic concepts of chemistry, and what else we will be doing? We will be doing GOC and thermodynamics. GOC and thermodynamics. Okay. Just give me a minute, okay? Just give me a minute. Okay. Okay, so I hope I am audible again. Okay, now we are good to start. Okay, now let's start without any delay. So we'll be doing some basic concepts of chemistry plus GOC and thermodynamics. These 3 chapters we'll be doing, so be prepared with your pen and paper, because these have, except GOC, these 2 have calculations. Okay, from today it will be available, because the course date is 6th of April, so it's starting from today only. From today you can see, and from tomorrow you can access all the lectures. Okay, today is the batch orientation, and tomorrow you will be able to access all the lectures. Okay, there will be an orientation class, trust me. Okay, I'll ask what is the timing exactly, but today is the orientation class. Okay, okay, so let's start first question. Select the incorrect statement. Tell me which statement is incorrect about significant figures. Okay, firstly let's see if this is correct or not. So first statement is 22 books have infinite significant figures. Is it true or is it false? So as far as my knowledge goes, when you write something like this, it has any number you write, like 10 you have written or 15 you have written, these have infinite significant figures. These have infinite significant. You have that, actually you have that mail ID, which is your edutube@gmail.com. One second, you have queries. What queries you have? One second, where is that mail ID? Ask edutube. You can ask your queries here. Ask edutube@diksharlearning.com. and learning.com. And if this is your correct name, I can even ask, if you have any other query, I can ask them to contact you also. Okay, okay, so let's start the class. Answer the question, guys. First class timing for Comet K 30. So you have doubts about Comet K a lot, right? So is it okay if I take your doubts in between when I think I have some time? Okay, I'll answer your doubt, timings and all. Actually, I have covered the schedule. Okay, I have told you about how the course will go in the next 30 days. So you can just watch that video also. In there, I have explained the full, that PDF is given. That PDF has all the details about which chapter will be starting there. It will be accessible in your app also. Okay, so you can check there. First class will be starting from tomorrow. You'll get access to all the one-shot lectures. Okay, and then after that your first class will be starting from 9 AM. Day after tomorrow, 9 AM, first class. Sarah, okay, no worries. For now, I'll actually ask someone. Okay, Sarah is your name, right? So if there is an issue, they will contact you. But as far as my knowledge go, the course is starting today, so there might be some issues. It's not showing. As the course is starting today, maybe you'll able to check today. Did you get the login details first? You need the login details, no? Okay, yes, everyone is answering C. Okay, let's see. 22 books have infinite significant figures. This is the correct statement. In the answer of the calculation, this. So how many significant figures? 2. And how many here? 3. Has 4 significant figures. So the least count, when you are multiplying, when you are dividing, the answer, the result will have the same number of significant figure as the least factor. So here the least factor have 2 significant figures. So in the answer also you will have 2 significant figures only. So this is your incorrect answer. Incorrect statement. Zeros preceding to first non-zero digit. So it's like this. Zeros preceding to first non-zero digit. This is the first non-zero digit, and it is saying that 0 preceding, coming before this non-zero digit are significant, which is incorrect, because 0 preceding the first non-zero digits are insignificant. Okay, so this is B and C, right? B and C. Let's check D also. In the answer of calculation of these, if you are adding again, the answer will have the same number of significant figure as the least factor. So here we have 4 significant figure, 3 significant figure, 1, 2, 3, 4. So again your answer will have 3. 3 is the least count, so your answer will have 3 significant figures. So that means this is also correct. What are the 2 incorrect statements? B and C. Okay, or most of you didn't check the option. The correct answer is option 1. The correct answer is option 1. How many of you answered 1? All of you are answering C. Narendra, C. Yet the full content has not been uploaded yet. The content will be uploaded, they'll start uploading from tomorrow only, okay? So the content is not there. It's not an issue, okay? If you are able to access some lectures, more of the lectures will be accessed by you tomorrow. From tomorrow onwards, they'll upload and everything, okay? Okay. What are you guys answering? D and C, D. At this point, damn. Answer was straightforward. Correct answer is option A. Okay? Correct answer is option A. Next question. Temperature of this in Fahrenheit and Kelvin scale. Very easy. You can convert it. Can you convert it? You converted it already. So when you convert degree Fahrenheit into Celsius, what is the formula? Degree Fahrenheit is equals to 9/5 times of degree Celsius plus 32. So what is here? 9/5 times of how many degrees Celsius? 25 plus 32. And if you solve it, 45 will be 7 and 7. 77 degree Fahrenheit. The answer is 77 degree Fahrenheit. Okay? Yes. Narendra, you are rage baiting or you are just playing with, because this is a very easy question. All the question you are answering wrong. So please stop spamming if you are answering it wrong on purpose. Okay, I'll explain, don't worry. Okay, Naveen, good. Yes. So see, very easy. We have to convert 77 degree Fahrenheit. So we have to convert this temperature into Fahrenheit and Kelvin. So when we convert degree Fahrenheit into degree Celsius, when we convert degree Celsius into degree Fahrenheit, what is the formula? So degree Fahrenheit is equals to 9/5 times degree Celsius. This is the temperature plus 32. What is the temperature here? Degree Celsius, 25 degrees Celsius, right? 9/5 times 25 plus 32. If you calculate it, the answer is 77 degree Fahrenheit. That means the correct answer is option A. You don't even have to check for this. But obviously we'll have to check if you want to convert degree Celsius. If you want to convert degree Celsius into Kelvin, then what is the formula? You add degree Celsius plus 273.15. That is your answer in Kelvin. Whatever the number is in degree Celsius, you just add 273.15 to it. You will get your answer in Kelvin. So let's see here. We have 25 degrees Celsius. If I add 273.15 to it, what will be my answer? 298.15 Kelvin. 298.15 Kelvin. That means the correct answer is option A, and as I see, most of you are answering option A only. Okay? Yes, correct. Correct, KK, Joe, Jill. In first question, but second, ma'am, in first question, but second option, if we multiple both the numbers, we will get 4 significant figures. Okay, I'll just explain 1 second. So Vijay Lakshmi Chandana again, who are answering correctly, I am taking their name only. Sanket also answered correctly. So Shankar, right? Your doubt is this, that ma'am, if we multiply them 2.5 times 1.25, that I will get 4 significant figures. But as I clearly remember, when we talk about significant figures, when we talk about product, when we talk about multiplication, division, addition, subtraction, in all these cases we follow one rule while dealing with significant figures. Obviously the answer will have 4, that's okay, but the correct will be the correct number of significant figures will be the number of significant figures that are present in the least factor, you can say. So if we have 2 numbers here and one have 2 significant figure and the other have 3 significant figure, so the answer, the product will have the same number of significant figure as the least factor, right? This least factor have only two significant figure. This is the least factor here, having only two significant figure. Basic rule. See, anytime you're doing addition, multiplication, division, subtraction, okay, in all of these operations, what do you use? So if you are given 2-3 numbers, okay, you calculate the significant figures in each and every one of them. Okay, let's say one has 2, the other has 5, and the 3 numbers are there, and these three have these 3 significant figures. Okay, now how will you see what will be your correct answer? So your answer will obviously come in larger numbers, because obviously up to 7 we have, right? But the correct number of significant figures, the acceptable number of significant figures will be the one which are present in the least factor. What is the least number of significant figure here? 2, right? So your answer must have 2 significant figure, must have 2 significant figure. Okay, that is a basic rule. Okay, if you have studied in your 11th standard, you would have seen it. Okay, okay, I hope it is clear, Shankar, right? So if it is have 2 and 3, then your answer will have what? Only 2 significant figures, only 2 significant figures, and here it is saying it will have 4 significant figures. That is incorrect. Okay, that is a rule actually, you should remember it while dealing with significant figures. This is how they work, okay, in operations. Okay, but while calculating, you calculate it normally. Okay, good. Okay, now let's move on to the next question. For which of the following uniform composition? Uniform composition means homogeneous mixture. Uniform composition means homogeneous mixture. Okay, so which among the following is a homogeneous mixture? Sand and water. No, they do not mix properly. The composition is not uniform throughout, right? Yes. Grains and pulses with stone, obviously you can separate them out, they are not uniform, right? The concentration, yes, it's not uniform. Yes, the dilute solution of aqueous solution of sugar and water, dilute aqueous solution of sugar. So sugar in water, yes, when you dissolve sugar in water, it dissolves completely. Yes, that is a homogeneous solution. The composition is uniform throughout. So that means that if you drink water from up here and from here, it will be equally distributed. The sugar will be equally distributed. Okay, homogeneous heterogeneous mixture, right? Okay, done. So correct answer is option 2. Any doubt you have regarding your questions, I'll answer it in the end. If you have any substantial doubt, that is. Why not? See, oil and water. Have you ever tried mixing oil and water, or are you living under a rock? So when you mix oil and water, water will be here and oil will be at the top. How is it uniform? Uniform means the concentration is constant throughout. The concentration is same or constant throughout. Is it constant? The oil is at the top, water is at the bottom, right? Okay. Next question. A pure compound. Here you'll need your calculation. So we have 2.4 gram carbon and 1.2 times 10 raised to power 23 atoms of hydrogen. And what else we have? We have 0.2 moles of oxygen. We have 0.2 moles of oxygen. You need to tell the empirical formula. You need to tell the empirical formula. Here you need your calculation. Here you need your calculation. Okay, so firstly, whenever you are given with questions dealing with empirical formula, calculate the number of moles. First should always calculate the number of moles. So here if you calculate the number of moles, 2.4 gram of carbon. What is the mass of carbon? 12, right? How many moles will be there? Moles will be 2.4 by 12. This many moles of carbon are there. Okay, what about moles of hydrogen? Now in this case, number of atoms are given, and we know in one mole of hydrogen we will have Avogadro number. In 1 mole of hydrogen we will have Avogadro number of atoms, right? Now we have this much. How many moles will be in this much atoms? It will be 1.2 times 10 raised to power 23 by 6.02 times 10 raised to power 23. Clear? And again, this is already given in moles. Okay, so if you calculate it, it will come out to be 0.2, and this will also come out to be 0.2 roughly if you do the calculation approximation. So everyone has 0.2, 0.2, 0.2. Okay, while calculating the empirical formula, your first step should always be calculating the number of moles. Second step, divide all the number of moles, all the moles by the least number of moles. So let's say we have 0.2, 0.2 and this was, let's say, 0.1. This is the least now, right? So in that case, you divide each mole by that least number of moles. Okay, so I'll just write here, divide. Second step is divide all the moles by the least number of moles. Why are we doing it? Because we see in maths we take common out of the whole equation, so it's like taking common here, right? We want a ratio, so that ratio we make by using the least amount. Okay, least amount, because if it is the least amount, then ratio would be substantial. In this case everything is 0.2, so you calculate the ratio: carbon, hydrogen, oxygen, 0.2 by 0.2, 0.2 by 0.2, 0.2, it is 1:1:1. Now empirical formula is the simplest molecular formula, right? It is the simplest form of your molecular formula, right? The point up to which we can simplify it. Okay, yes, so the correct answer is 1:1:1 means D, and all of you answered D. Yes, all of you answered, yes, correct. All of you answered D. The correct answer is D. Why? Because the ratio is 1:1:1. 1:1:1. Clear? So always whenever you're dealing with empirical formula question, follow these two steps. Calculate the number of moles. Then after calculating the number of moles, divide all the moles by the least number of moles. And the ratio you will get, that will give you the empirical formula. Okay, quick question. What is the relation between empirical formula and molecular formula? What is the relation between empirical formula and molecular formula? Okay. Next question. A gas mixture contains 25% helium and 75% methane. So helium and methane. Helium is 25% and methane is 75%. At given temperature and pressure. Okay, I think by reading this first statement, I remember one law which is similar to it, right? Gay-Lussac's law, if I'm guessing right. Gay-Lussac's law, right? At a given temperature and pressure, volume of a gas is directly proportional to the number of moles. Right? At a given temperature and pressure, the volume of a gas is directly proportional to the number of moles of that gas. Okay, that is the Gay-Lussac's law. What is that law? Gay-Lussac's law. Okay, now we have to calculate the percentage by mass of methane. Only one is asked, percentage by mass of methane. Now what is percentage by mass? If I remember correctly, percentage by mass means mass of methane that is present here, mass of methane divided by total mass. What do you mean by total mass, ma'am? Total mass means mass of helium plus mass of methane, right? Mass of methane divided by mass of methane plus mass of helium, and times 100, because we are talking about percentage. Okay, we are talking about percentage. Okay. Rishabh, actually every year cutoff changes, so no one can predict it. First of all, okay, we can just give you a basic idea that from the past year the cutoff is going in this range, and you must score this much to, like, this much cutoff got this much rank and all. So every year it's different. Okay, so no one can predict it. I'm sorry, I can't help you in that thing, but I do know that in KCET 50% weightage is of your PU1 and PU2, your PU boards, 50% weightage of your PU2 boards, and 50% weightage of your KCET marks. Okay. D. So every one of you is answering 75%, but actually it's incorrect. You solve the question. If this question is easy for you, it's a KCET question. Some question may be easy, some question may be hard. What do you want me to repeat? You have been like spamming messages for so long. Don't do that first of all, because I can't see the answers given by other students. And what you want me to repeat, please mention that question. I will answer it at the end of the class. Okay, not right now. Okay, now tell me. Mass of CH4 is, you need to calculate. You need to calculate, read the question. You need to calculate the percentage by mass of methane. Okay. So firstly, as I told you, according to Gay-Lussac's law, at a given temperature and pressure, volume of any gas is directly proportional to the number of moles. So that means if we have a gas, what we should assume, if we have 100 mole of a mixture, 100 mole of a mixture of these two gases, in that 25 moles of helium and 75 moles of methane will be there. 25 moles of helium and 75 moles of methane will be there. Okay, now if you know the moles, if you know the molecular mass, can you calculate the amount? Yes, you can calculate, because number of moles is equals to what? Given mass upon molecular mass. We know the molecular mass for both of them. We know that. We know the number of moles also, right? We can calculate this mass, and this mass is being asked. This is the mass that is being asked. Okay, clear? Mass of CH4. Okay, now how do you calculate it? Your mass of, we just need to calculate the mass of methane first. That is 75 times molecular mass. 12 plus 4, 16. 16. So that should come around 75 times 16, 1200. Yes, the answer is 1200 grams. Similarly, you calculate the mass of helium. Why? Because it is needed. We want to calculate the percentage by mass. Mass of helium will be equal to what? We have how many moles of helium? 25 moles. And what is the mass? 4. The mass of helium is 4. Yes, it is 4. So 100 grams. Okay. So now if you put the value here, mass of methane is 1200 grams divided by total mass is 1300, right? 1300, 1200 plus 100. This is the total mass times 100. And your answer should come around 92%. It should come around 92.3 something, right? 92.3%, which makes it up to 92%. Okay, 92%. Okay. B. Yes, now everyone is answering B. Okay, KK. Bhumi again. Okay, done. So believe them if you want to, Rishabh, but no one can exactly predict it. Every year it's unpredictable. It depends on the paper. It depends on the number of students that appeared in the exam. Okay. So every year, plus the number of seats that are available in colleges. So many factors are being considered. Okay. No one can predict it 100%, but yeah, they can give you a basic idea as I told you. Okay. Yes, Shravant, Nitra, Malik, Sesha, Jilan, Malik. Again, everyone is answering correctly. Okay. All the best. Yes, this is PYQs, Jilan. Okay. Now let's move on to the next question. 0.4 gram of dihydrogen is made to react with 7.1 gram of dichlorine to form hydrogen chloride. The volume of hydrogen chloride formed at 273 Kelvin and 1 bar pressure. So what is the reaction happening here? You have hydrogen combining with chlorine and we are getting HCl. Okay. Now 0.4 gram of hydrogen is combining with 7.1 gram of chlorine. Okay. And some amount of HCl will be formed. So you need to calculate the volume of HCl formed. So how will you approach these kind of questions? Okay. They all follow a similar approach. Okay. Firstly, you calculate the number of moles. Okay. I'll write here. Number 1, calculate number of moles. After calculating the number of moles, you identify the limiting reagent. The trick I'll tell you, don't worry. LR is limiting reagent. Okay, after identifying the limiting reagent, yes, after identifying the limiting reagent, you just calculate, because whatever be the amount of hydrogen chloride produced will be directly proportional to the amount of limiting reagent present. Because what is limiting reagent? It is the fun agent that limits the reaction. Okay, this is the limiting reagent. If it finishes, the reaction will stop on its own. Okay, so the answer, third one is calculate the moles of product. So we'll follow these three steps. Firstly, we'll calculate, and Cl2 will have, if I'm roughly calculating, 35.5. So it should have 0, 1, 10, 1, 1, 16, 16 something, 1 second. How much I did calculate here? 71, 35.5, yes. Square. No. Okay. Yes, it should come around 71, yes. So here number of moles is 0.2, number of moles is 0.1, 0.2 and 0.1. Now one more thing here, ma'am, A is the correct answer. Let me check. Yes. So whenever you're dealing with concept of limiting reagent, first of all, it's very confusing, I know, but you always calculate the number of moles. Now after calculating the number of moles, here it is easy, but in some questions you won't be able to tell, because there will be some stoichiometry written here. Here the ratio is 1:1, 1:1. Okay, that means 1 mole of H2 and 1 mole of Cl2 is required. But we have 0.2 mole of H2 and 0.1 mole of Cl2, which is the least, 0.1. So that means this is your limiting reagent. This is your limiting reagent. This only works if you have the ratio between the reactants as 1:1. If this only works if you have the ratio between the reactants as 1:1. So that comes out to be 0.2. Okay. Sorry, 0.1 is your limiting reagent. Okay, this is your limiting reagent. Okay, now after identifying the limiting reagent, where step 1 is done, step 2 is done, you calculate the mole of HCl. Now see here, 1 mole of Cl2, 1 mole of chlorine produces how many mole of HCl? 2 mole of HCl, right? How many moles we have now? 0.1 mole of Cl2. 0.1 mole of Cl2. So what will be the amount? It will be 2 times 0.1, that is 0.2 mole of HCl. Now we are given the number of moles. The answer is being asked in volume. The answer is being asked in form of volume. Okay, how to do if there is any stoichiometric coefficient? In that case, you normally, I'll explain, some questions are there which have different stoichiometric coefficient, that I'll also explain. Okay. Do we have some questions actually? Yes, we do have 1 to 2 questions. So don't worry, we'll explain there. Okay. By example, you will understand it much better than this. Okay. Good morning, Prajwal. It's okay. Yes, if the ratio is different, the answer will be different. Okay. In that case, I'll tell you how to calculate. Okay. First, focus on this. If 1:1 ratio is there, then simply you can see that 1:1, both needs in equal amount, but we have only 0.1 mole of Cl2. That means Cl2, chlorine is our limiting reagent. So using that limiting reagent, we calculate, we predict the amount of product getting formed. Okay, now this is the amount. Now we need to calculate, convert it into volume. How do you convert it? So we have one formula to calculate the number of moles if volume is given. So in that case, it is equals to given volume upon molar volume. And molar volume is, what is the molar volume? Molar volume is 22.4 liter at STP. 22.4 liter at STP, standard temperature and pressure, which is 273 Kelvin and 1 bar pressure. Okay, you can calculate number of moles by mass, by number of atoms, and by volume. 3 things are there. Okay, always remember it. You can calculate number of moles by mass, by volume, and by number of atoms. Okay. Okay, now if I put the value here, I want this given volume. This is 22.4. Number of moles is how much? 0.2. 0.2, so it will be 0.2 times 22.4, and if we calculate it, 4.48, which is almost similar to 4.5. 4.48, which is almost similar to 4.5. So yes, some of you instantly answered option A. You guys are correct. Madhvika, have you enrolled in the course? Have you purchased the course? Then today is the batch orientation. You will get the details today only. Okay, if you have joined the WhatsApp channel also, you will get the updates there also. Okay. Yes, Netra answered A. Okay. Okay, Madhvika, Shesha, Bhuvan, hello, hi everyone. I purchased it yesterday. Did you get the login details, Madhvika? Did you get the login details? Did you join the WhatsApp channel also? Okay, starting from today, okay, and you have the batch orientation today, and from tomorrow you'll be having the lecture access. Okay, now next question. The mass of AgCl precipitated when a solution containing this much gram of NaCl and this much gram of AgNO3 is added. Okay, so you again, similar to that last question, firstly you calculate the number of moles. This is the reaction here. AgNO3 plus NaCl gives AgCl plus NaNO3. Now tell me, how much is the amount of AgNO3? AgNO3 is 3.4 gram of AgNO3 we have, and 11.70 gram of NaCl we have. Okay, we'll calculate the number of moles. So AgNO3 and NaCl, how much mass will be there? For AgNO3 and NaCl, 58.5 and 170. 170 and 58.5, right? And if you calculate it, answer is 0.2 for this and 0.02. Again, the ratio is 1:1. If the ratio is 1:1, then obviously which is lesser here? AgNO3 is lesser here, so it is your limiting reagent. Once you identify the limiting reagent, 80% of your work is done. Once you identify the limiting reagent, okay, I'll explain it once again, but after we finish all these questions. Okay, question number 6, if you stay till the end of this some basic concept one, I'll explain whatever question doubt you have. Okay, now let's focus on this one. AgNO3 and NaCl, we calculated the number of moles, which has the lesser number of moles. As both are in the ratio 1:1, AgNO3 has the lesser number of moles. So this is your limiting reagent. Now, how do you calculate the number of amount of AgCl? It should be in direct relation to this. How? So 1 mole of AgCl, 1 mole of AgNO3 gives 1 mole of AgCl. 1 mole of AgCl. How many moles you have? 0.02 moles of AgNO3. That will give how much? 0.02 mole of AgCl. 2 mole of AgCl. Okay, but you are asked the amount in mass, in terms of mass. Okay, so you have the moles, you have the molecular mass, you can calculate the mass, right? Mass will be equal to what? Number of moles times the molecular mass. So number of moles is 0.02 times molecular mass. What is the molecular mass? 108 plus 35 we are taking, 3, 4, 143. .02 times 143, and if you calculate it, 0.02 times 143, 2.87. The answer would be 2.87. Option C, not D. Option C. Okay, you guys are not studying, I think. C. KK, Bhuvan. Okay. C. 2.8. Yes, Channa. Done. Bhagya, KK, Jilan, everyone is answering correct. Okay. Prajwal. Done. Okay. So the correct answer is option C. How do you calculate it? Simple. Firstly, calculate the number of moles, identify the limiting reagent, and then calculate the amount of product formed. And then you can convert, interconvert also in mass, number of atoms and volumes. Okay. Next question. 1 gram of, see here we have different ratio. You'll see the answer. You'll have different ratio here. So magnesium and oxygen combine to give magnesium oxide. Here the ratio is 2:1. Here we can't just predict using the number of moles. Okay, so how will we do? We are given 1 gram of magnesium is burnt with 0.28 gram of oxygen in a closed vessel. Which reactant is left and how much? So we are asked about the excess reagent. Okay, limiting reagent we know. The one that is not the limiting reagent, it is the excess reagent. So firstly, calculate the number of moles. We have 24 divided by 32. 24 divided by 32. Okay, this is 0.0416 and this is 0.00875. Now by looking at it from, like, if you see, this is the much lesser amount, ma'am. This should be the limiting reagent, but see, the ratio is also different. So we will calculate. How? Let's say we are taking oxygen. We'll start from oxygen. 1 mole of oxygen requires how many mole of magnesium? 1 mole of oxygen requires 2 mole of magnesium. 2 mole of magnesium. That is here given. 1 mole of oxygen requires 2 mole of oxygen. How many moles of oxygen we have? 0.00875. If we have 0.00875 mole of oxygen, how many mole of magnesium is required? 2 times of 0.00875. 2 times of 0.00875, which is 0.0175. 0175. This is the amount of magnesium required. But how much magnesium we have? We have 0.0416. We have 0.0416. So obviously it is in excess. The magnesium is in excess. So what is the excess reagent here? Magnesium. So either option A or option B. The excess reagent is magnesium. Okay. Now after calculating the excess reagent, how much we need to calculate? How much is left? Okay. How much amount is left? Now see, this much amount is needed by oxygen to form magnesium oxide. Okay, so this much amount is getting reacted, and subtracting this, whatever amount is left, that is the answer. Okay, so here this much amount is getting reacted and this is the total amount. So our answer will be 0.0416 minus 0.0175 0.241. Okay, this is the number of moles. Mind you, these are the number of moles. How do you calculate? Again, you calculate the weight by multiplying by 24. If you multiply it by how much? 24. Yes. If you multiply it by 24, your answer will come out to be 0.58 gram. 0.58 gram. Correct answer is option B, not A. No, it's not A. Why are you confused, Joe? I will tell again. Once again, I'll repeat this here only. Now focus. So firstly, write the balanced chemical equation, calculate the number of moles. I think up till here everything is clear. After calculating the number of moles, you need to identify the limiting reagent. Now this here, the reactants are not in same ratio. The ratio is not 1:1. The ratio is 2:1. So you need to figure out using the ratio which is in excess, which is in limiting. Okay. So we calculate, we take oxygen. Least you can pick, right? 1 is easy. Multiplication is also easy. So 1 mole of oxygen requires 2 mole of magnesium. 1 mole of oxygen requires 2 moles of magnesium. Okay. How many moles of oxygen we have? This much, 0.00875. If you have 0.00875 moles of oxygen, how many moles of magnesium will be there? 2 times this amount. 1 mole of oxygen requires 2 moles of magnesium. 0.00875 mole of oxygen will require 2 times of this, right? That is around 0.0175 moles of magnesium. Now how many moles of magnesium we have? We have 0.0416. Now if you see here 0.0175, 0.0416, which is larger? This one. That means the amount we have is greater than the required amount. The amount we have is greater than the required amount. If that is the case, that means this is our excess reagent. Magnesium is our excess reagent. Now how much magnesium will be left? So this is the amount required, right? If this is the amount required by oxygen to form magnesium oxide, so whatever is there after this, whatever amount is there, that is the left amount, right? Because only this part will react with oxygen. This is the required amount. That means only this part will react with oxygen, right? And rest we have, that is our excess. That is our excess reagent. So how much will that be if I subtract this? This is the total amount. This is the total amount. And if I subtract this amount from there, this is the amount that has reacted. Okay. So whatever amount is left is our excess amount. The excess amount is being asked. Okay. The excess amount is being asked. Okay. So the answer come in mole. Okay. The answer came in mole. And how do you convert mole into mass actually? So mass is equals to number of moles times the molecular mass. Again 24. Answer will be 0.58 gram. I hope it is clear. Don't worry, I think I'll have to repeat these questions again once I finish it. Okay, I'll repeat it once again. If you just be familiar with it. I know limiting reagent is a very scary concept, and if you have multiple reagents, then obviously it's much scarier. Then in that case, you'll have to apply that method to, for example, let's say your sulfur was also there by some chance, then you'll have to calculate oxygen, this much magnesium, oxygen with sulfur. Okay, then you'll see among all these three, which is the least amount, that will be your limiting reagent. Same ratio method, simple ratio method is there. Okay, no, I'm not taking no break. I'm not giving you any break. I want to finish it. Okay, and because I'll have to repeat it once again to you all. So the correct answer is option B. Joe, I hope it is clear. Okay, now let's move on to the next question. This much molecules are removed from 98 milligram of sulfuric acid. The number of moles of sulfuric acid left are. This much molecules are removed from 98 gram of sulfuric acid. 98 gram of sulfuric acid. Okay, done. So 98 milligram, right? 98 milligram. So firstly, you calculate this much moles are removed. Okay, firstly you calculate 98 milligram have how many molecules? Reading the question might be a little tricky, but read it. If this much molecules are removed from 98 milligram of sulfuric acid, that means this is the total amount. Initial amount is 98 milligram. Okay, so the total number of molecules that are present in 98 milligram, will calculate that, and out of those molecules, this many molecules are removed. This many molecules are removed. Okay, we need to calculate the number of molecules, moles that are left. Number of moles that are left. So obviously there will be some conversions, but we have an idea that we'll calculate the total number of molecules, and this much has already been removed. So if we just remove that amount from the total one, we will be left with the left amount. We will be left with the left amount. Very easy. Like, it's actually very easy concept if you think about it. So let's say this is, we have 98 milligram of H2SO4. Okay, this have like 100 molecule, let's say. Out of these 100, it is saying 30 molecules have been removed. Let's say 30 molecules have been removed. So that means this mixture have now what? 100 minus 30, which is 70 molecules only. 70 molecules only. That is what we will do here. Okay, with some little spice actually of chemistry. Let's see. Okay. So if we have 98 milligrams, so how many molecules are there? 98 milligram means 98 times 10 raised to power minus 3. Minus 3 grams. So number of molecules, if you want to calculate the number of molecules, firstly we calculate the initial moles. We'll calculate the initial moles. because as far as I remember, in terms of molecule, the subtraction and that thing is very difficult. So we'll convert both into moles. We can convert it, right? One mole in this much 98 gram. How many moles are there? Calculate it first. (0.001 moles. What is it? 0.001 mole. Okay, this is the initial number of moles. Okay, now number of moles, we convert this data also, the number of molecules into number of moles. How many number of moles will be there that are removed? 3.01 times 10 raised to power 20 by 6.02 times 10 raised to power 23. Your answer will be 0.1 by 2. 0.5 times 10 raised to power minus 3. This is the number of moles that are removed. This is the number of moles. You know, right, how to calculate the number of moles? B. Actually, no, you are doing the calculations again. A. Okay, so this is the number of moles that are being removed. These are the initial moles. These are the initial moles. You need to calculate the amount that is left. The amount that is left. How much is it? 0.0005 minus 0.001. This is the total mole. Total mole minus the mole that are removed. So how much we will be left with? It's 0.5 times 10 raised to power minus 3. 0.5 times 10 raised to power minus 3, because it will be 0.0005. So that is 0.5 times 10 raised to power minus 3. A is your correct answer. Okay, let's walk through it once again. Yes, I'll repeat, Chandra. See, this we are given a 98 milligram solution of sulfuric acid. From that solution, this number of molecules are being removed. This number of molecules are being removed. You are asked the number of molecules, number of moles that are left. Okay, so just remember, we are given weight. Okay, from that particular weight, number of molecules are being removed, right? And the answer, the left amount, the amount that is left is being asked in terms of mole. Simple, right? We know there are three things: mass is there, molecules is there, moles is there. So we'll just convert all of that data into one single information. How? Firstly, we'll calculate if 98 milligram is there. If 98 milligram, that is the amount, initial amount. So how many will be the number of moles? Firstly, we calculate the number of moles. How many will be the number of moles? How do you calculate number of moles? Given mass upon molecular mass. Given mass is 98 milligram, which is 98 times 10 raised to power minus 3 gram. Okay, molar mass, molecular mass is 98 for sulfuric acid. So if we calculate it, initial moles comes out to be 10 raised to power minus 3 mole, which is 0.001 mole. That is your initial mole, right? The amount that you took initially. Now from this amount, how many molecules have reacted? This much molecules are being removed. Okay, so you calculate the number of moles that have been removed. How many moles have been removed? See, number of moles. If molecules is given, you can calculate the number of moles, right? How? Number of moles, number of molecules that is given divided by the Avogadro number. Number of molecules that are given divided by the Avogadro number. Okay, if we calculate it, the answer comes out to be 0.5 times 10 raised to power minus 3. That means this is the number of moles that are removed. These are the initial moles. These are the number of moles that are removed. What is the amount left? Total amount minus the amount that is removed. The amount that is left, that will be your answer, right? So if 0.001 minus 0.005, that is 0.5 times 10 raised to power minus 3. I know the question may seem a little tricky, and ma'am, we don't know how to go with the flow and all. Very easy. Read the question 2-3 times at least, and then see what data you can convert. Normally, if you start with calculating the moles, the answer become a little easier. Okay, so obviously there are multiple ways to attempt this question. This is the quickest way. Okay, 98 milligram is there. You calculate the initial moles. Okay, we are given certain amount of molecules also. From molecules you can also calculate the moles. From molecules you can also calculate the moles. Okay, you calculated the number of moles. This is the number of moles that are being removed. These are the total number of moles, initial moles. Okay, so if you subtract the moles that are removed from the total moles, you will get the left amount, right? And that is being asked the number of moles that are left. So the correct answer is option A. A, yes. Hina, the thing is, I know this chapter is a little tricky, okay, but you need to know the basic. I can help you only as such actually. You need to actually understand the basic. You're not understanding anything. I'll just give you a little, okay, just be with me. Number of moles. Number of moles is a very important concept in some basic concepts of chemistry. How do you calculate number of moles? There are three ways. You calculate number of moles by mass. You calculate number of moles by number of molecules. And you calculate number of moles by volume. Okay, number of moles. This is a very important concept. Okay, are you with me, Hina? Okay. Okay. Now, how do you calculate the number of moles using mass? So that is given mass. That is the amount of that particular substance or that particular reactant or any compound that is given amount divided by their molecular mass. That's how you calculate the number of moles if mass is given. If number of molecules are given, as in this case the number of molecules were given, then how you calculate number of moles? So number of moles in that case will be given number of molecules, divided by Avogadro number. Avogadro number, because 1 mole of any substance, 1 mole of any substance in this whole, on this whole planet, 1 mole of any substance is equals to Avogadro number of molecules, which is 6.022 times 10 raised to power 23. Clear? That's how you calculate the number of molecules. That's how you calculate the number of moles using number of molecules. Okay, or number of atoms, molecules, atoms. Okay. Volume. If the data is for gases, for gases volume will be given, right? For gases and liquids also. So in that case you use this concept volume. How do you calculate the number of moles using volume? That is equals to given volume, the volume that is given to you, divided by molar volume. Now this molar volume is a fancy name for the volume at STP. Molar volume is the means the volume of 1 mole of any substance, 1 mole of any gas, okay, or any substance. Okay, so that is 22.4 liter at standard temperature and pressure. That is 22.4 liter at standard temperature and pressure. Okay. In some basic concepts of chemistry, you just calculate the number of moles. That is only there. That is the only thing that is there. You remember these 3 formulas, okay, and you use them. And you use them depending on the data that you are given. So this much molecules are being removed. So I don't know how many moles are there. How will I calculate it? If this much molecules are being removed, if I divide it by Avogadro number, that will give me the number of moles that are being removed. So these are the number of moles that are being removed. Now how many moles were actually there? That amount is given, 98 milligram is there. So if I am given the mass, given mass is there 98 milligram. Molecular mass of sulfuric acid I know. So total moles, initially the total moles were 0.001 mole. Okay, now the reacted moles I know, total moles I know. This are the removed mole, this is the total mole. If I subtract them, I will be left with the number of moles of H2SO4 that are left. Okay. It's like, you know, if you have a water bottle, if 1 liter, if you remove, let's say, half liter of water, how much water you will be left with? half liter, how do you know that? You can subtract it, right? 1 minus the amount that is left. 1 minus 0.5, 0.5, right? So similarly here, this is the total amount minus the amount that is removed, you will get the amount that is left, okay? It's very easy. You're just complicating it in your head because you don't know the basic. You write down these formulas, okay? It's very easy, okay? Today is the batch orientation, Kani, okay? And from tomorrow it's officially starting. Attending the batch orientation is a must, because otherwise you won't know where to look for your courses, where to look for your lectures, how to access the DPPs, and everything will be explained today only, okay? What was her name? Hina. I hope it is clear now. Is it clear, Hina? Okay. Yeah, so don't be scared. Take one step at a time. No one knows the answer in first instance. Next question. Again, you have to calculate empirical formula. So firstly, calculate the number of moles. Calculate the number of moles. Okay. So we have carbon, hydrogen and nitrogen. Carbon is 40%, 13.33%, 46.67%. Nitrogen has 14. Molecular mass. See, this is the given mass I'm taking. So I'm assuming that the organic compound is 100%, right? In that 100%, 40% carbon, 13.33% hydrogen, nitrogen is this much. So I'm taking it as a literal weight only, okay? So this is the given mass. This is the given mass, okay? Now if I divide the given mass by molecular mass, I will get the number of moles, right? 12, and hydrogen has 1 actually, right? So the answer will be 3.33, 13.33, 3.33. Now which is the least number of moles here? 3.33, right? So you complete all the number of moles by, divide all the number of moles by the least number of moles. Why? Because we want a ratio, right? Because we want a ratio. So if I divide it by 3.33, which is the least number of moles here, 3.33, 1 is to 4 is to 1. 1 is to 4 is to 1. Okay. So the correct answer is, means carbon is, how many carbons are there? Empirical formula is the simplest whole number ratio, right? C1, H4 and N. N is also 1. So C4, CH4N. CH4N. Yes, finally somebody answered. Empirical formula times N factor gives us molecular formula. Correct, Venkatesh. Okay, C. Yes. So again, whenever you're calculating empirical formula, calculate the number of moles. After calculating number of moles, divide them with the least number of moles, so that you get a whole number ratio. That is your that is your empirical formula. And if you divide it, if you multiply it with N factor, you will get your molecular formula. Okay, good to go. Yes, I think Nalin, you came back so late. Okay, Sesha, Nalin, Venkatesh, Nandini, Hina also answered correct. Yes, Chandana, good for you guys. Yes, finally. Okay, yeah, one more thing. Again, if you have not joined the batch, this is just an update that the batch is now at a price of 1999, okay, 1999, 2000, okay. Use the code 500 of KC30 and you will be able to access it, okay. Again, we have that lectures and PYQs and all the mock tests are going on there. So if you are looking for, like, if you now want to enroll it, the price has been dropped. Okay, now GOC. Are you ready for GOC? Now before that, I should go back to one question because I won't be able to go back later on. This one. 6th question, right? Yeah. 6th question. So in 6th question, it's okay, Nalin. Yes. 6th question was your doubt, right? Some of you were asking, was it your doubt, right? 6th question, right? One of you. Whose doubt was it? I don't know, but you asked that this question is your doubt. Okay, so in this question, this much gram of hydrogen is reacted with this much gram of chlorine to form hydrogen chloride. You need to calculate the volume of hydrogen chloride that is formed. Volume of hydrogen chloride that is formed. Very easy, right? How? Because we know this reaction is happening here. H2 combining with Cl2 gives 2HCl. That is the reaction that is happening here. Now we are given the amount. The given mass is here. The mass is given 0.4 gram of hydrogen, 7.1 gram of chlorine, right? So firstly we calculate the number of moles of both. Hydrogen has 0.2 and chlorine has 0.1 moles. Then we identify the limiting reagent. How do you identify the limiting reagent? So the ratio is 1:1. 1:1. That means 1 mole of H2 requires 1 mole of Cl2, right? 1 mole of H2 requires 1 mole of Cl2. 0.2 mole of H2 will require 0.2 mole of Cl2, right? If we have 1 mole of H2, 1 mole of H2 requires 1 mole of Cl2. That is given by this equation, right? Now we have how many moles of H2? 0.2 moles of H2 will require how much mole of Cl2? 0.2 mole of Cl2, but we have only 0.1 mole of Cl2, right? So in that case, what will you do? This is your limiting reagent. That means it will limit the reaction. How do you calculate your limiting reagent? This is how you calculate the number of moles, that you calculate the ratio. Take any 1 mole of H2 requires 1 mole of Cl2, right? Other way you can also go. That will also work. That will also work. Okay? Clear? Now once you calculated the limiting reagent, the calculation became very easy. Why? Because then you just equate it with the product. So 1 mole of Cl2 gives 2 mole of HCl. That is what we can get from this equation. 1 mole of Cl2 gives 2 mole of HCl. So 0.1 mole of Cl2 will give how many moles of HCl? 0.2 mole of HCl. The answer is being asked in terms of volume, not in terms of moles. Okay, so you'll convert the number of moles into volume. How? We know moles can also be calculated from volume. How? Moles is equals to given volume divided by the molar volume, which is 22.4 liter at STP, right? Given volume we need to calculate. Number of moles we already know. Molar volume is already known to us, 22.4 liter. Given volume will be equals to 0.2 times 22.4, which is 4.48, which comes out close to 4.5 liter. 4.5 liter. Okay, that was your doubt. I hope it is answered now. And whenever you are calculating limiting reagent, you cannot calculate on the basis of number of moles only. You need to calculate the amount that is required. Here, for example, 1 mole of H2 requires 1 mole of Cl2. That means 0.2 moles of H2 will require 0.2 mole of Cl2. But we only have 0.1. That means this is your limiting reagent. Okay. Similarly, for this question also, 1 mole of AgNO3 require 1 mole of NaCl to give 1 mole of AgCl, right? So which is the limiting reagent? That means 1 mole of AgNO3 requires 1 mole of NaCl. 0.02 moles of AgNO3 is given and 0.2 moles of NaCl is given. So 0.02 requires how much? 0.02. 0.02 moles of AgNO3 will require 0.02 moles of NaCl, right? But we have 0.2. That means it is in excess. This is not the limiting reagent. That means NaCl is in excess. Which is our limiting reagent? AgNO3 will be our limiting reagent. Okay. Either way you can calculate it. Either way works just fine. Okay. Either way works just fine. Pick any one reagent and you start from there. Okay. Okay, I hope this limiting reagent concept doesn't scare you anymore, okay? Because the questions that are being asked from this chapter are very basic, okay? They're not going into too complicated reactions. Very simple and easy reactions are there. Okay, now let's start with GOC. In this one, we don't need calculation obviously. In thermodynamics, we'll need though. Okay, let's start with GOC. First question, what is the answer? Start naming actually. Where do we start from? If we start from here, 1, 2, 3, 4. That is one option, right? The double bond is at 2 and the substituent, which is our halo compound, that is halogen, is at 4. Locant is 2, 4. Okay. Now, if I don't want to name it this way, I'll name it this way. 1, 2, 3, 4. So in this case, the locants are 1 and 2. 1 and 2. So obviously this is our least locant, so we will follow this nomenclature, right? We will follow this nomenclature. Be quick. What should be the name? At 1 we have bromo, so the name is 1-bromo. But 2-ene. 4 carbons are there, right? And at second position we have the double bond. So but 2-ene. Yes, the correct answer is option A. The correct answer is option A. We applied the lowest locant rule here. Why? Because if we name from here, 2-4 is coming, and if we name from here, 1-2 is coming. Okay. Okay, now let's move on to the next question. The IUPAC name for this one. Now here you have a different thing to deal with. You have 2 functional group here. You have 2 functional group. One is ketone and the other is carboxylic acid, which is given more priority. Which is given more priority? So carboxylic acid is given more priority than ketone. So if carboxylic acid is given more priority, you guys are just chatting, you're not studying at all. Okay, so if yes, carboxylic acid is given more priority. Okay, so that means this will act as a substituent. This will act as a substituent, right? So we'll start naming from here. 1, 2, 3, 4, 5, right? 1, 2, 3, 4, 5, obviously, because the functional group should get the most priority functional group. The primary functional group should get the least number. Okay, so it should be 4 oxo. Yeah. For ketone, the the substituent name is oxo. For ketone, the substituent name is oxo. 4 oxo. And how many carbons are there? Pentanoic acid. 4-oxo-pentanoic acid. Clear? The priority order is important when you are naming. The priority order, remember it. Okay. Done. Okay. The correct answer is option B. Yes. Hazira, B. Everyone is coming late. It's okay. B. Yes, the correct answer is option B. Next question. Which of the following is not an isomer of hexane? Hexane. So this is an isomer of hexane. Yes. How many carbons? 6 carbons. 3, 6 carbons. 3, 4, 5, 6 carbons. So all these 3 are isomers. Yes, but this is not hexane. This is cyclo compound. This is a cyclo compound. Cyclo compound, right? Cyclo compound. So this is not an isomer of hexane. This is not an isomer of hexane. Okay. Good morning. Yeah, good morning. B. Yes, correct. Correct answer is option B. Which of the following is not the functional, not a pair of functional isomers? So what are functional isomers? They have same functional group. No, not a pair of functional isomers. We have position which have same functional group. Functional isomers means same molecular formula but different functional groups. Yes, but different functional groups. Let's see. These have different functional groups, right? Not a pair. Okay, these have different functional groups and same molecular formula. Okay, similarly, this is not the correct one because these have different functional groups but same molecular formula. Different functional group, aldehyde and carboxylic acid, but same molecular formula. Same number of carbon, same number of hydrogen and oxygen. Okay, but these two both are ethers. They only differ in the number of carbon atoms on either side of the functional group. They only differ in the number of carbon atoms on either side. Here 2, 2, here 3 and 1. Okay. They are isomers. What are these? They are metamers. The name is metamers. These kind of isomers where the number of carbon atoms on either side of the functional group is different, that is your metamers. Okay, so these are your metamers, not functional isomers, not functional isomers. Yes. Next question. Correct statement. Okay. Dimethyl ether and ethanol are chain isomers. Chain isomers have different carbon chain. Different carbon chain. Here they are not just chain, they are what? They are functional isomers. Dimethyl, yeah, they are functional isomers. Okay, they are functional isomer, not chain isomers. Ethanoic acid, methyl methanoate, one is ester, one is carboxylic acid. They are position isomers. Position isomers should have same functional group, but differ in the position of functional group. Okay, so obviously this is also not the correct answer. N-butane, isobutane are functional isomers. Again, functional isomers have different functional groups. Both have same. Both are alkanes only. So this is not the correct statement you need to identify. Yeah, this is not the correct statement. So this is your correct statement. Both are alcohols and they only differ in the position of the functional group. Same functional group but only differ in the position of functional group. Okay. See. D is your correct answer. Next question. A pair of compounds having the same boiling point. Same boiling point. That means same intermolecular forces. Okay, bye bye. Yes. No. Same molecule, same boiling point means same intermolecular forces are there. Similar level of intermolecular forces are there. If we have cis butene and trans butene, so normally your cis isomer has higher boiling point than trans isomer. Cis isomer have higher boiling point than trans isomer. The reason being, when we are dealing with cis isomer and when we are dealing with trans isomer, so in trans isomer there is no polarity, right? Because they are opposite to each other, both the bonds and the charges cancel out. In this case, because of the polarity, cis isomer have higher boiling point than trans isomer. Again, N-hexane, neo-hexane, not much of a difference. No, there is a difference actually. Hexane is straight chain. It is straight chain. Neo-hexane means there is branching. That means there is branching. Like this. And whenever branching is there, boiling point decreases. Why? Because surface area decreases. Right? Again, benzene, naphthalene. Benzene has only one ring and naphthalene has how many? 2 rings. Naphthalene has how many? 2 rings. Okay, so obviously higher molecular mass, that means higher boiling point, not same. So only this part, these are enantiomers. Plus minus means these are enantiomers. Only enantiomers have same physical properties but different chemical properties. Enantiomers have same physical property but different chemical properties. In physical properties, we talk about melting point, boiling point, density, and refractive index. These properties are same and rest chemical properties, that means the chemical reactions are different. Okay, D, K, Siddharth, M, D, Rehan, Chandana, Rahul, A, Y, Hazira, D, Shrikant, D. Okay, so correct answer is option D. Next question. Which of the following compounds possess the CH bond with the lowest bond dissociation energy? So firstly, you should be aware what is bond dissociation energy. So bond dissociation energy is the energy required to break a bond homolytically. So this is the energy required to break a bond homolytically. That means in this case we are getting what? Radical. We will be getting radical and what? If the radical is stable, this process will happen quickly, because if after breaking I am getting stability, I would want to do that rather quickly, because every atom, every compound in chemistry wants to gain stability, right? And if that radical is stable, then this process will happen really fast. That means little bit energy you give, that bond will break on its own. Okay? Yes, so B, C, somewhere in between you have B option, C option. Okay, now let's see. In benzene, is let's say I break the CH bond in benzene. Obviously we are talking about the CH bond, okay, not the CC bond, okay. So in benzene, if I break this bond homolytically, what will I get? I will get a benzene radical. Is this stable? Obviously this is not stable, this is highly unstable. Similarly 2,2-dimethyl propane, 2,2-dimethyl propane, we need to break the CH bond. Where is the CH bond? Here, 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 right? So if we break the CH bond, let's say I break here. If I break this bond, this radical will form. Is this a secondary, tertiary? What kind of radical? This is a primary radical, only connected to one carbon. This is a primary radical. Is this stable? No, it is not stable. So obviously it won't have the lowest bond dissociation energy. Toluene. Okay, let's see toluene. In toluene we have this CH3, right? So if I break this bond, I will get this radical. This is benzylic radical. What is this? This is benzylic radical, and benzylic radical is extremely stable. The benzylic radical is extremely stable. You know the order? Benzylic radical is more stable than tertiary radical, then secondary, then primary. And this phenyl radical is the least stable. Phenyl radical is the least stable. This is your answer. Okay, so the correct answer is the bond with the lowest bond dissociation enthalpy will be this toluene, will be toluene. Toluene. Okay. No, Sujata, not D. C. Yes, Rohan. Nalin, Chandana, Shrikant. Yes, Rohan. Something is going on. Okay, yes, the correct answer is option C. Okay. Correct answer is option C. Next question. What is this? This is oxidation, right? Oxidation of alcohol to aldehyde. Oxidation of alcohol to aldehyde using PCC. Navin, okay, don't worry, somebody will contact you today, okay? Regarding any queries you have, somebody will contact you, okay? I'll share your details to them, don't worry. I'm not ignoring, I'm just teaching, and I have told you be patient. They take some time to respond, but I will forward your query to the team and all, okay? They will contact you, okay? Now see, what is the change in oxidation state? Sorry, what is the change in hybridization? So here we have only this, all the bonds are same, only this carbon is undergoing change from CH2OH to CHO. What is the hybridization here? All the carbon bonds are single bonds, right? So it is sp3 hybridized. Here we have double bond. We have a double bond. So double bond means it is sp2 hybridized. So hybridization is going from sp3 to sp2. The correct answer is option B, not C. Correct answer is option B. Okay. Okay. Next question. The number of pi bonds and sigma bonds present in naphthalene. I will not calculate it. You will calculate it. I'll draw the structure of naphthalene here. Calculate the number of pi bonds and the number of sigma bonds. Calculate the number of pi bonds and the number of sigma bonds present in naphthalene. Okay. Also, yes. Also, don't forget there are bonds here also. 1, 2, 3. There are bonds here also. Carbon-hydrogen bonds. There are also sigma bonds. Okay. Similarly, here also. But here I don't think 1, 2, 3, 1, 2. Here we don't have. Okay, 1, 2, 3, here, and here. Okay, so these are all hydrogens. So if you calculate it, it has 5 pi bonds and 19 sigma bonds. 5 pi bonds and 19 sigma bonds. Okay, clear? Yes, everyone clear. Okay. Next question. Resonance effect is not observed in. So I have told you that resonance effect is only observed when you have a double bond, single bond, double bond, right? Or a double bond, single bond, lone pair, right? Or a triple bond also, same way it works, okay? So you have few cases actually, okay? 1 second. Yeah, or you can have a double bond, single bond and an empty orbital. This is an empty orbital. In all of these cases you will observe resonance, okay? Now let's see here, double bond, single bond, double bond, obviously resonance will be there, okay? See, double bond, single bond, triple bond, resonance will be there. Double bond, single bond, but here ma'am, how will resonance possible? So Cl has lone pair of electrons. Cl have lone pair of electrons. In this case, the delocal resonance happens like this. Resonance happens like this. This is vinyl chloride. Okay. So this is also showing resonance. Now see here, double bond, single bond, double bond, single bond, and we have a single bond. Double bond, single bond, single bond. Is there any resonance? Nope, there is no resonance. This is your correct answer. It will not show any resonance. It will not show any resonance. Not B. Shrikant, not B. B is showing resonance. Double bond, single bond, triple bond. That I can also write here. Double bond, single bond, triple bond. These are the cases for resonance. Number 1, 2, 3, 4. These 4 cases are there. Resonance will happen when there is a double bond, single bond, triple bond, double bond, single bond, double bond, single bond and a lone pair, double bond, single bond and an empty orbital. Okay, in that case also resonance happens. So here only this one is not satisfying any of the conditions. So that's why it is not showing resonance effect. Not showing resonance effect. Okay. Tiffin. What Tiffin? Yes, Shrikant D, Bhumi D, Hina D, Hina, Vijay. Okay, Leela. No, Leela, you answered B. Yes, Shrikant also D. Hi, Heman. Okay, and now let's move on to our next chapter, which is thermodynamics. Let's see how much you have in you now. Okay, are you ready? Are you ready for thermodynamics? Ma'am, answer is D. Yes, Shrikant, answer is D. I don't understand Kannada. Kannada gottilla. Okay, so tell me, from the diagram, this diagram, you have to calculate delta HR, which is the enthalpy change from delta HR. Okay, from it is given, delta HR is given. You have to calculate delta H from the process C to A. Change in enthalpy from going from C to A. Okay, these are given. This is 10 joule, this is 25 joule. Okay, these are given. Now tell me, do you know a law called Hess law? Ever heard of it? Hess law. Name is written there. Hess law. So according to Hess law, the enthalpy change is the same whether you go. So according to the scientist Hess, he said that whether you go like this, let's say I have 2 points, A and B. He said the enthalpy change is same whether you go straight, whether you go by this path or whether you go by this path. Okay. Okay, so whether you go by several steps, whether the reaction proceed in several steps or in one single step, okay, the enthalpy change will be the same. Okay, so if let's say here this is around 10 joule, so this whole will come out to be 10 joule only. Okay, enthalpy change, if it goes via one single step or in multiple steps, the enthalpy change will always be same. So that means if I'm talking about going from C to A, okay, so I can also go from C to B to A. That is also an option, C to B to A. That will also give me the enthalpy change, right? So whether I go in one single step and whether I go in multiple step, the enthalpy change for the process will be same, So I go from C to B and B to A. So this should be equal to delta H from C to B plus delta H from B to A. Okay. Now if I am going from C to B, the enthalpy change is simple, 25 joule. Okay. So this means 25 joule. If I am going from 2B to A, B to A to 2B is 10 joule. A to 2B is 10 joule, but I am going in opposite direction. So enthalpy change will change, right? In this case, this reaction is endothermic, right? Plus enthalpy change is positive. That means the reaction is endothermic. But if I go from this to this, the sign changes. Why? Because this reaction, the direction I have reversed, right? In opposite direction, enthalpy change also reverses, right? So it will be minus 10 joule. So your answer will be 15 joule, plus 15 joule. Plus 15 joule. Okay? Yes, the correct answer is option D. So again, according to Hess law, if a reaction goes in a single step or in multiple step, the enthalpy change of the single step is equal to the sum of the enthalpy changes of the multiple steps. Okay, so here we are asked the enthalpy change for the single step, straightforward step. We can go by this step also, right? That will give me the same value, right? So I went from C to 2B and 2B to A. C to 2B is 25 and 2B to A. A to 2B is 10 joule. So when I go in the reverse direction, I will reverse the value of delta H also, enthalpy change also, okay? It will become negative. Okay? Simple, right? Distance displacement may you do, right? If direction changes, the sign also changes in case of displacement, physics, right? So the correct answer is tomorrow result for PU2. Okay. Next question. Statement 1 and statement 2. Adiabatic work done is positive when work is done on the system and internal energy of the system increases. So you know one first law of thermodynamics, right? What is that? First law of thermodynamics. First law of thermodynamics, according to first law of thermodynamics, change in internal energy is equals to the sum of, that is not the first law actually, the statement is the internal energy of an isolated system is constant. That is the statement. Internal energy of an isolated system is constant. Okay. And one more thing is that if that whole statement, which is like similar to conservation of mass, we have a conservation of energy also. But the statement, the mathematical form is this. This is the mathematical form of your first law of thermodynamics. Delta U, change in internal energy, is equals to the heat plus work done. Heat plus work done. When we talk about adiabatic work done, what is there? In adiabatic work done, Q is 0. Why? Because no heat is being exchanged between the system and surrounding. No heat is being exchanged between the system and surrounding in case of adiabatic work done. Okay, so Q will be 0. If Q is 0, delta U is equals to W. Now for work, one thing is being said here. That work is done on the system. So when work is done on the system, don't merge your physics here. When work is done on the system, it is positive. When work is done by the system, it is negative. Okay. So work done on the system is positive and work done by the system is negative. Clear? So work done is positive. So if work done is positive and work is equals to change in internal energy, that means change in internal energy will also be positive. Internal energy also increases, right? So that means this statement is correct. Now second, no work is done during free expansion of an ideal gas. So when you do free expansion, what do you mean by free expansion? That means you are expanding the gas in vacuum. Okay. So if you do expand the gas in vacuum. Is there any pressure? What is the condition for vacuum? When the external pressure is 0. In vacuum, the external pressure is 0, right? Because that's why it's called vacuum, right? There is no atmospheric pressure, nothing there. The external pressure is 0. That is your vacuum. So if external pressure is 0, that means P external is 0. If P external is 0, we know work done is equals to minus P external dV. Minus P external dV, which is the change in volume, right? Right? Okay, and now P external is 0. That means work done will be 0. Work done will be 0. No work is done during free expansion of an ideal gas. No work is done during free expansion of an ideal gas. That means this statement is also correct. So your correct answer is option 3. Option 3. Now let me see how many of you answered option 3. A, not Mohammed. No, that is not the correct answer. Okay, option C. Yes. Nalin, Shisharu. Okay, done. Clear. Okay, next question. The work done when 2 moles of an ideal gas expands reversibly and isothermally. So remember this condition, reversibly and isothermally. So when work done is done reversibly and isothermally, work done is calculated using this formula, minus 2.303 nRT log of V2 by V1. V2 by V1. V1 is the initial volume and V2 is the final volume. Okay. Temperature is given 300 Kelvin because process is isothermal, right? So that means temperature is constant here. So I just put all the value here. Minus 2.303 times, number of moles are 2, times R. R is already given 0.0083 times temperature, which is 300 Kelvin, log of V2 by V1, which is 10 by 1. So if I just calculate it, how much will be the answer? How much will be the answer? Minus 11.46 kilojoule. So which is similar to minus 11.5 kilojoule. Here we are talking about the magnitude, because see, no positive negative sign is there, so we are talking about the magnitude only. Okay, so what is the magnitude? 11.5. 11.5. Okay. C. Yes, the correct answer is option C. Next question. Which of the following has delta H equals to delta U? Firstly, you should know what is the relationship between delta H and delta U. Delta H is change in enthalpy, which is equals to change in internal energy plus delta Ng RT. Delta Ng is what? Number of gaseous molecules. Delta Ng is number of gaseous molecules of reactant, now product minus number of gaseous molecule of reactant. Okay, so if delta H is equals to delta U, that means this thing is 0. Delta Ng RT is 0. Now R is a gas constant, it has some value. Temperature is also not 0 here. Okay, so what is 0 here? This delta Ng is 0. That means same number of molecules are present in the reactant and product side. Same number of gas molecules are present on the reactant as well as the product side, right? Only then this delta Ng will be 0. Number of gaseous molecule of product minus number of gaseous molecule of reactant. Now let's check for this reaction. 6 gaseous molecules in the product side and here 15 by 2. So answer will be 6 minus 15 by 2. That is not 0. Here H2 plus I2, 2 and 2HI minus 2. Yes, in this case the delta Ng, there are 2 gaseous molecules on the product side and 2 gaseous molecules on the reactant side. So 2 minus 2 will be 0. So that means option B is your correct answer. Let's check here also. We have 2 and here 3 and 1 4. 2 minus 4, that is minus 2, not 0. Similarly here also we have only one gas molecule. Only one gas molecule. All are solids. Okay, so it is delta Ng. If delta Ng is 0, then delta H will be equals to delta U. So the case is Delta Ng is what? Number of gaseous molecule of product minus number of gaseous molecule of reactant. If this is 0, then your delta Ng is 0. That means in that case delta H is equals to delta U. Nalina, I have no idea the KCET exam timings. So normally you give 2 exams, one in the morning, one in the evening. Okay. Physics and chemistry are on 23rd, and then maths and biology are on 24th. Exact timings I don't know, but you have 60, you'll be given 80 minutes and all, but obviously you'll be getting 60 minutes to solve the questions. So one in morning, one in the evening. It's like that. Okay. Physics, chemistry one day, and maths and bio one day. What is going on here? Okay, just let me finish the questions. Okay, I'll answer all of your doubts. Okay, you don't have any academics doubt, you have other doubts in your mind. Okay, the reaction in which delta H is greater than delta U. So delta H will be greater when delta H is greater than delta U. When delta H is equals to what? Delta U plus delta Ng RT. Delta Ng RT. So it is greater. Delta H will be greater than delta U when this amount is positive. When this amount is positive. Okay, some amount is there. Now let's check for the first reaction. 2 and 1 and 1, 2 minus 2. This is 0. So that means for this delta Ng is 0. So in this case delta H will be equal to delta U. Here see 1, only 1. So here obviously delta H will be equals to delta U plus RT. Something is getting added. Delta H is equals to change in internal energy plus RT. That means delta H is greater than delta U, right? Okay. Now let's check all these options too. 2 minus 4, that is minus 2. So in this case delta H will be equals to delta U minus 2 RT. So here the value is less. Delta H is less than delta U. Why? Because we are subtracting this 2 RT. We are subtracting this 2 RT. Okay. Similarly here let's see 1 and 2 plus 1 3. 1 minus 3, which is again minus 2. So again same delta H will be less than delta U. Change in internal energy. Okay. Delta H is change in enthalpy. Delta U is change in internal energy. Yes, the correct answer is option B. Yes, the correct answer is option B. The correct answer is option B. We are looking for delta H should be greater than delta U. When it will be greater, when this factor delta Ng RT is positive, when it is getting added. So only in one case it is positive, and rest all the cases it is negative or 0. Okay. Next question. I kinda regret now adding this question here, because okay, let's solve. It's very easy, but for you guys it will be tough because you don't have the basic. Yeah, you have problem. I can see that you have problem. Okay, you have A2 combining with B2 and we are getting AB. So half of A2 combining with half of B2, we are getting AB. The ratios are 2 is to 1 is to 2. These are the bond enthalpies ratio. Bond enthalpy of formation is given. Enthalpy of formation is given. So enthalpy of formation means that you are synthesizing any compound by its constituent atoms. So for example, we have methane. Methane is made up of carbon and hydrogen, right? So if we synthesize methane using carbon and hydrogen, that is the enthalpy in that case. Ya to either you will give the energy, either energy is absorbed or the energy is released. That energy change is enthalpy of formation. Energy change associated when 1 mole of any compound is synthesized from its constituent atoms. Okay. Constituent atoms at their standard conditions. Okay, so carbon has standard carbon, right, and hydrogen is stable as H2. So in this way it is synthesized. Okay, so what is happening here exactly? Half of A2 combines with half of B2 gives AB. This is the balanced equation. Okay, these are in the ratio 2 is to 1 is to 2. The enthalpy of formation is given. So enthalpy of formation is equals to what? Delta HF is minus 100 kilojoule. Okay, now focus. Enthalpy of formation is equals to the enthalpy sum of the enthalpy change of reactants minus sum of the enthalpy change of products. Clear? It is equals to the sum of the enthalpy change of reactant minus sum of the enthalpy change of product. So what is the sum of the enthalpy change of reactant? The ratio is given. This is the ratio, right? So we can convert it into 2x, x and 2x, x we need to figure out. Okay, now see. Enthalpy change of reactant, half A2 and half B2 is there. So that means, okay, half A2 and half B2 is there. That means half A2 and half B2 is there. That means x by 2x by 2 plus x by 2 minus product is 2x, right? So if we calculate it, it will come out to be x plus x by 2, which is 3x by 2 minus 2x minus x by 2, and this is equals to what? Minus 100 kilojoule, right? So minus 100 equals to minus x by 2, x is equals to 200 kilojoule. Now we need to figure out this value, right? We need to calculate the bond enthalpy for B2. What is the bond enthalpy for B2? X, right? And what is the value of X? 200 kilojoule. 200 kilojoule. Clear? Okay, yes, the correct answer is option C. Okay, same formula. Whenever enthalpy of formation is given, you calculate it like this. It is equals to the difference in the sum of the enthalpy change of reactants minus sum of the enthalpy change of products. Okay, so these are the reactants. Why I divided by this? Because these stoichiometry is important. You divide by, you multiply with this stoichiometry, right? And then you calculated it. The answer came out to be 200 kilojoule. Yes, correct answer is option C. Some of you are actually listening. That is actually, I am very grateful. Shankar, Rahul, yeah, Nalin. Okay. Next question. It is kind of similar. Again, bond energy is given. So, how do you synthesize HBr? H2 plus Br2 gives 2HBr. Okay, so again, how do you calculate the delta H naught for this reaction? How do you calculate the delta H naught for this reaction? C is the answer. C. Let me check. Nope, the answer is not C actually. Again, in this case also, the change in enthalpy will be equals to, the change in enthalpy is equal to again the enthalpy change will be equals to the sum of the enthalpy change of reactant minus sum of the enthalpy change of products. Okay, so in case of reactant we have how much? H2 and Br2, which is 433 plus 192 minus product 2 times of 364. So your answer will be minus 103 kilojoule. Option D. Option D. Okay. Next question. when the same quantity of heat is absorbed by a system at two different temperature. Okay, this is more of a common sense question than this thermodynamics question. So listen carefully once. When we have two systems, let's say we have a system A and we have a system B. Okay, system A has more entropy. Entropy means randomness. Entropy means randomness. This is going there, this is going there, here, and this have less randomness. Let's say this have less randomness. Okay, in A the randomness is more than in B. Okay, we have two temperatures, T1 and T2 also. Okay, if I increase the temperature, okay, so we have these two conditions. We have a system A, we have a system B. System B has higher randomness than system B. System A has higher randomness, right? Higher entropy change than B. Okay, the temperature is T1, the temperature is T2. T1 is greater than T2. Now what is happening? Now what we did, we added heat. If we add heat, what happens? If we add heat, see, this is already high in randomness. Okay, so much entropy heat it have. Okay, this have lesser randomness, less amount of randomness you can say, or lesser entropy. Okay, if we put more heat to it, if we supply more heat to it, what do you think will happen? So in this case, A, it is already at its maximum limit. Okay, if it is already at its maximum limit, and if you are providing more heat, will it go into the entropy change or the randomness, will it increase really much, like, you know, a big expulsion, like very much change in the entropy? No. Why? Because it is already too much high. It already have too much randomness. Okay, but for this, since this has lesser randomness, lesser disorder, okay, what happens if we provide heat? This will increase really high. This randomness will increase substantially. Okay, so it's a more of a common sense based question than your thermodynamic. So which will have, after supplying the heat, which will have higher randomness? This will have higher randomness after supplying this heat. This B will have higher randomness than A. This is delta S1 and this is delta S2. So initially, good morning Dikshit. Okay, so initially we have two systems, A and B. A is more random, more disordered than system B. It is at a higher temperature. Now if we supply heat to both the systems, so since A is already at a very high order of randomness, high disorderness, even if we supply heat, the disorderness will not increase much. But B is already at lower limit. And if you supply heat to it, the randomness will increase very much. Greater than this one. Okay, so after that what will happen? Delta S2 will become greater than delta S1 if you supply the heat. Good morning everyone. Actually, not good morning, I'm saying goodbye also. Okay, this is the last question. A reaction is delta H and delta S negative, the rate of the reaction is. So this is actually a tricky question, very easy. You can answer yourself also. It's a tricky question. We are talked about rate. We are given the thermodynamics parameter. Rate is related to which? Kinetics, right? This is related to kinetics and these things are related to thermodynamics. So they are just trying to trick you. Rate of the reaction is very easy. It is increasing with increase in temperature. Rate of a reaction increases with increase in temperature. That is the simplest criteria. We know that, right? We know that. Yeah, goodbye. Okay. Yes, done. So this is just to trick you guys. This data is given to trick you guys. This data actually works when we are being asked of spontaneity. If we are being asked of spontaneity, then this data is important. But otherwise, if we are being asked of rate of reaction, then this data is not important. Okay. So rate of reaction increases with increase in temperature. Okay. Okay. Done. That is it. Yes. Okay. Okay, thank you so much for the class. It has been a really long class. Okay, I hope you understood it. Three things are there, Alpha Soul. Temperature, you are talking about temperature. Actually, for an isothermal change, how is work done? 1 second. For an isothermal process, the temperature is constant, right? The temperature is constant. Now, since the temperature is constant, there is no change in energy. Internal energy is 0. For isothermal process, change in internal energy is 0. Change in internal energy is 0. But work done is a different thing. Work done can be done by pressure, volume, PV work we call it, right? Mechanical work you can do by your own hands also, right? So even if the energy is not there sometimes, okay, the internal energy is 0 in case of your in case of isothermal process. But obviously there is heat is there, right? It is not 0 in case of isothermal process. Due to this heat, work can be done, right? Also due to mechanical mechanical work is also there, PV work that we call it. From that also work can be done. But for isothermal process, change in internal energy is 0. Rate of reaction has nothing to do with delta H and delta S. Okay. Yes, temperature is constant. Temperature and heat energy are different. Okay. Temperature and heat are different. They are not the same quantity. When there is no heat exchange, see, in that case there is no heat exchange, so this work gets directly converted into internal energy. In that case, your work gets directly converted into internal energy, because for adiabatic process Q is 0, then obviously whatever work you are doing, it is directly getting converted. Adiabatic work done is equal to the change in internal energy. I think next class will be my last class. I think so. Okay, I think done. Thank you everyone. Thank you for attending the class. We'll see you in the last lecture. I think 3 chapters are left. We'll finish those chapters in the next class. Okay. Okay, good question. One second. We are left with PU1 chapters are there. Okay. Let me just check once. Yes, we have structure of atom, periodicity, chemical bonding and molecular structure. Structure of atom, periodicity, chemical bonding and molecular structure. These 3 chapters are left. Okay. Okay everyone, thank you so much. See you in the next class. Okay, hopefully you come study. Please be prepared. Structure of atom, chemical bonding, molecular structure, periodicity of properties. Okay. Okay, goodbye everyone, and do like this session, and obviously take care. All the best for your exams. Okay, bye.